Welcome back, everyone. Now that we've looked at what are units, what are physical quantities, what are their dimensions, let's look at what is the use of all this. Why are we studying dimensional analysis at all? Yay! The first use is it helps us convert units. So from the CGS system to SI system or vice versa, or to FPS system or any hypothetical system of unit. So let's try this out. Before we start with the example, let's understand one formula, which is N1U1 is equal to N2U2. I'll write that again. N1U1 is equal to N2U2. These are numbers, okay? This is a number. This is also a number. And U1 is the first system of units. For example, it can be SI system, and U2 is another system of unit. It can be a CGS system. So let's say we've measured a physical quantity, for example, force. Now, force is measured in newtons. We all know that its unit is Newton. If I expand this, how Newton looks like, it's kg meter per second square. If I write the dimension of this, kg is mass, meter is length, and seconds is time, so t minus 2. This is the dimension of force. Let's say the measured value of force is 5 Newton or 5 kg meter per second square. Now the question is 5 kg meter per second square is equal to how many dynes? And dynes is actually grams centimeters per second square. So this is what we have to find out. What we do next is we use this trick which says N1U1 is equal to N2U2. So this one is your N1. This thing represents unit 1, okay, is one system of units. Let's call it the SI system of units. We have to find N2. And we also know the other system of units, which is the CGS system. Let's call it U2 for the time being. I hope this explains the formula which is given here. N1U1 equals N2U2. N2 is to be found out. So if I just shuffle these things, so N2 will be on this side. This thing goes to the other side of the equal to sign. See, what we have is 5 kg meter per second square upon gram centimeter per second square. Okay, this second square is going to get cancelled. This part is the same, so it gets cancelled. Okay, but kg meter and gram centimeter, how do we cancel these? Kg, convert kg into grams. 1 kg is 1000 grams and 1 meter is 100 centimeters. So we get N2 as 5 into 1000 into 100. These many dynes. Okay, so we got the value of N2 as 5 into 10 to the power 5. You substitute that value here, we have our answer. Okay, so this helps in unit conversion. When we have to deal with hypothetical units which we haven't seen, something like this question which we are going to see now. So in this question it says the density of a material in SI unit. So this is our first system of units. The density of the material in this SI unit is given. So N1 is known to us. In a different system of units, in which the unit of length is this, the unit of mass is this, what is the numerical value of density? So this numerical value which we have to find out is our N2. So let's use that formula, how to convert from one system of units to the other system of units. N1 U1 is equal to N2 U2. N1 is 128, U1 is kg upon meter cube. This is equal to N2. N2 is unknown to us, so we'll leave it like that, N2 as a variable. U2. U2, what is the unit of mass in the second unit? The unit of mass is 50 grams. So you write 50 grams here. And what is the unit of length in the second system of units, in the new system of units, in the hypothetical system of units? It's 25 centimeters. Okay, so 25 centimeters, whole cube, remember, 128 kg upon 50 grams. And here we have meter cube. And in the numerator, we'll have 25 centimeters whole cube. This will give us the value of N2. You solve this and you'll get the answer. Let me quickly do that. You can do it on your own. So this goes like this. So the final answer is 40. So that's your answer. Okay. This was one application of dimensions.